Hello dear listeners. In this video, we will demonstrate the process of balancing using the vibration analyzer ADL MS52 with balancing functionality. It's worth noting that such a function is also present in the devices ADL MS52 Pro, ADL MS54, and ADL MS54 Pro. The balancing programs are identical across all these devices, so I will demonstrate this function using one of them. To conduct the balancing, you will need scales, trial weights, a rotational speed sensor, and a vibration sensor. First, let's measure the vibration to determine the initial vibration level and understand how balancing can assist in this situation. The device indicates a vibration reading of 32.5 mm per second, which is a very high vibration level. Next, let's check how the vibration level decreases with the help of balancing. Next, without turning off the equipment, I switch to the balancing mode and create a new task. Subsequently, it is essential to determine at what rotational frequency the balancing needs to be conducted. To do this, I press the F2 button, and the rotational speed sensor automatically calculates the value, which is then entered into the device. After that, we select the correction plane. In this case, there is only one, vertical. We will be adding mass, not removing it. There is also a location mode, which is necessary if the device, for example a fan, has a certain number of blades. Before starting the balancing process, the device notifies about the necessity to check the sensor selection, as each sensor has its own serial number and amplification coefficient. It is important to verify this before commencing the balancing process. We initiate the balancing mode. The device searches for the heavy point and does not indicate any errors regarding the rotation frequency, confirming the accuracy of the entered rotation frequency. The device locates the heavy point, we save it, and proceed. Then, the device asks to set a test weight. We hang 1 gram at angle 0. We weigh our load on the scales. For convenience, there is marking on the equipment. If you don't have it, it is advisable to create it. We start the equipment. Please note that the vibration may either worsen or improve. Whether we remove or leave this load will depend on how much the vibration has worsened. Next, we continue the measurement, press start, and note that the vibration improved due to the test weight. We continue the process, and the device suggests keeping or removing this mass. Given that the imbalance decreased, we leave this weight, press start, and the device calculated that it is necessary to hang 1.84 grams at a 360-degree angle, in the same location where the previous weight was installed. We press start. The device reminds us to ensure that the sensor is installed. On the device, we see the initial imbalance, a trial load, and a point closer to the center, indicating that balancing has been performed. Next, the balancing can be continued and carried out further. On the screen, we see that the device requests to further hang a weight of 0.88 grams at a 225-degree angle. However, in this case, it is necessary to check how much the vibration has decreased. Therefore, we save the measured values. Next, we enter the analyzer mode, turn it on, and conduct the measurement. The vibration level has decreased by more than 3 times. Understanding that this is an educational stand, the reduction in vibration is still very good. Next, it's possible either to continue balancing or to start over. Let's try to continue. Go to the menu, select the balancing mode, and proceed with the task. Press Start. The device automatically loads all previously entered values. We press Start to check the values, then press Start again, and it asks to place 0.91 grams at angle 223. We stop the equipment, select the angle, and hang the weight. We continue the measurements by pressing the Start button. We observe that the vibration has slightly reduced. We continue balancing and save the results. Then we switch to the analyzer mode and see how the vibration level has changed after the balancing procedure. We managed to reduce the vibration level to 8.1 mm per second. This balancing process aims to reduce the vibration level. Considering this is an educational setup, using more powerful equipment and more precise angle calculations and weight measurements could lead to an even more significant reduction in the vibration level. Thank you for your attention.